I want to review factoring a little bit because as we move forward and we start to work with quadratic equations and other things that we're going to see later on in the year, factoring is going to show up in many of the topics that we're going to see going forward. So just a little review on what we learned in Algebra 1, and I realized that when we do different techniques one by one, we have less of a problem because we know that that one technique that we're working on is the one to use when we're doing homework. However, later on when we learn many of the techniques and we have to put it all together in a quiz or a test, we get confused, which technique we have to use, exactly what type of situation we're seeing. So that's one of the things I wanted to go over today is how to recognize those different things and how to handle them. So this flow chart that you have in front of you talks about the sequence on how to look at these expressions when you're asked to factor them. So the first thing you need to do when you get an expression to factor is take a look at it to see if there's a greatest common factor greater than 1 that you can take out of the expression. So if you can do that, you're going to be left with one of the 3 items that you see on the bottom. Even if there is no greatest common factor, or GCF, you'll be left with either a binomial, a trinomial, or something larger. And generally what we're going to deal with for our purposes is something with 4 terms. So if you see larger here in the flow chart, we're really dealing with 4 items. So 4 terms. Trinomial, as you know, is 3 terms, and a binomial, 2 terms. So once you factor out the GCF, we'll realize there is no GCF to factor out. You'll see that you're left with one of these 3, binomial, trinomial, or something larger with 4 terms. And you'll proceed down the column that you see here with respect to what to do. So for example, if it's a binomial that you're left with, you want to check to see if that binomial represents the difference of 2 squares. If it does, then it shows you in the box the technique that you're going to use to factor it. And we'll go over some examples in a minute. Further down the chart, it talks about the difference of 2 cubes and the sum of 2 cubes. And we're going to hold off on that and deal with that a little bit later because, again, right now we're dealing with quadratics. So we'll concentrate on that right now. In the trinomial column, you notice that we're looking for a couple of different things. We're trying to recognize if we're seeing a perfect square trinomial. We're looking to see if it's not a perfect square trinomial, if a is equal to 1, because there'll be one technique to apply. And if it's not a perfect square trinomial, if a is not equal to 1, yet another technique to use. And we'll go over those techniques in a minute. And then finally, if you have something that's larger, 4 terms, we'll use a grouping technique to factor those. So when you're working with these different expressions that they want you to factor, you want to take a look at this flow chart to help yourself recognize what it is that is presented to you and what technique needs to be used in that situation. If we take a look at this first one, we see that we have 2 terms. And again, at the top of the flow chart, it wants us to take out a GCF if possible. So the greatest common factor here, if we look at the numbers 28 and 7, would be 7, because 7 goes into 28 and also into 7. If we look at the variables, we have an x in each term. So we have a common factor as far as the variables go. And when you take out a common factor for the variables, you want to go with the variable with the lowest exponent. So we're going to take out x as a common factor since x to the first is a lower exponent than x squared. So to get what goes in the parentheses, basically what you're doing is dividing each term by that common factor. So essentially we're doing 28x squared divided by 7x, and then we're doing negative 7x divided by 7x. So if we divide here, 28 divided by 7 gives us 4, and x squared divided by x gives us x to the first power, right? We subtract these exponents when we're dividing. And then negative 7x divided by 7x gives us a negative 1. So after we take out the GCF, we're left with a binomial. So the next thing to do is look at the binomial column, see if we have the difference of two squares there. Since we don't, then our final answer, we stop here, and our final answer will be 7x times 4x minus 1. All right, so here we have 3x squared plus 6x plus 15. So top of the chart says factor out a GCF. So if we look at the GCF, we can take a 3 out, since 3 goes into 3, 6, and 15. By the way, if you're working with larger numbers and the GCF isn't as apparent and doesn't come as quickly, you can use the calculator to find that. For example, here, if we get a calculator screen and we want to know the GCF between 3, 6, and 15, here's what we did. We can go to Menu and Number. Number 5 here is our greatest common divisor. So that's the same thing as our greatest common factor. So we'll hit that. And what you do is put the numbers in separated by a comma. So we had 3 and 6, so separated by a comma, and the GCF is 3. If you have more than two numbers like we do here, we have a 15 as well that we have to consider. Start with the first two, get a GCF, and then use that result with the next number. So again, if I go into number and greatest common divisor, now I want to use this result, the 3 that I have here, with the 15, which was the last term in that expression, and my GCF is still 3. So that's what we have here. We have 3 taken out as the GCF. So again, it's just that essentially we're dividing each term by that GCF. So in the parentheses, we'll have x squared plus 2x plus 5. So once we do that, we again realize that we're left with a trinomial here, and we want to go through the flow chart regarding the trinomial. So the first thing it asks us to do is check to see if we have a perfect square trinomial. So quickly, we take a look at whether the first and last terms are perfect squares. We need the first term to be a perfect square. We need the last term to be positive and the perfect square. And in this case, the 5 is not a perfect square, so we can eliminate the perfect square trinomial aspect of this. It says in the next box, a is equal to 1. Well, that's the case here, right? Because we know there's a 1 in front of the x squared. So it says we're looking for something that multiplies to c and adds to b. So in this case, we're looking for something that multiplies to 5 and adds to 2. So if you take a look at the factors of 5, it's basically 105. So no combination of those two numbers will give us a 2. So this can't be factored any further. So we stop there, and our final answer is 3 times x squared plus 2x plus 5. Here we have something that looks a little bit different. We are going to check if there's a GCF that we could factor out, and there isn't anything in common here. So we take a look. We have 2 terms going down the flow chart. That brings me to the binomial. So I have to look and see if we have the difference of 2 squares. So when I look at the first term, I can take the square root and get a perfect square. because the square root of 4 is 2, and the square root of y squared is y. When I look at the last term is 1. When I take the square root of 1, I get 1. So each of those terms is a perfect square. That tells me that I have the difference of 2 squares. So looking at the box, the technique here is once we identify that it's the difference of 2 squares, we're going to set up 2 sets of parentheses. One set will have a plus sign, the other a negative sign. And then very simply what we do is in the first position, we take the square root of the first term. So we said that was 2y. We put that in the first position in both parentheses. The square root of the second term, 1, is 1. So we're going to put that in the last position in each parentheses. And we have that the factors for 4y squared minus 1 are 2y plus 1 and 2y minus 1. Okay, something similar here. Again, we look to see if there's a GCF. There's nothing other than 1 as a GCF here, so we notice that it's a binomial, so we move down in the chart to the binomial. And again, we're trying to recognize if the difference of 2 squares exists. So since 144 is a perfect square and x squared is a perfect square, we do have the difference of 2 squares. Again, the technique is to set up 2 parentheses, 1 plus, 1 minus, and we take the square root of the first term, 144, that's 12. That goes in the first position since it's in the first position in the original expression. Then we take the square root of x squared, that's x, and that goes in the second position, and we're done. Okay, so here in this expression, again, top of the flow chart says, can we take out a GCF? So I look at 4, 24, and 36, and 4 is the greatest common factor for all of those. So we'll write down a 4 here. I look at the variables. I can't take a GCF out for the variables only because 36 does not have an x attached to it. Only the first 2 terms have an x. So I can't take that out as a common factor. So only the 4 is our common factor. All right, again, dividing each one of the terms by the common factor, we're left with x squared minus 6x plus 9. Okay, so now we notice that after we take out the GCF, we're left with a trinomial. We go to the trinomial part of the flow chart, and we see the first thing we have to look for is whether or not we have a perfect square trinomial. So again, the way to do that is to see if the first term is a perfect square, which it is, and whether the last term is positive and a perfect square, and that is also the same thing. So when you have that condition where it's a perfect square trinomial, the technique is, first of all, we bring down the GCF. The technique is to set up one set of parentheses and square it. We look at the sign of the middle term in the trinomial and use that in the parentheses. Next, we take the square root of the first term and put that in the first position. So the square root of x squared is x. We take the square root of the last term and put that in the second position. And we have this factored out. We have 4 times x minus 3 squared. Now you're wondering, what about the negative 6x? Well, basically, to make sure that you've got the correct factors, what you can do is, don't worry about the signs. Just take a look at what's in the parentheses and multiply it together. So if we multiply the x and the 3 together, we get 3x. Double it, we get 6x. That's what we see here, so we know we have the right factors. Okay, we want to see if we could take out a GCF to start. There is no GCF other than 1, so we're going to go to the next thing on the flow chart, which is we recognize this as a trinomial. So again, first thing to examine is whether or not we have a perfect square trinomial. So it looks like the first term is a perfect square, and it looks like the last term is positive and also a perfect square. So we do have a perfect square trinomial. Again, the technique for that is to set up one set of parentheses and square it. We're going to fill in the parentheses with the sign of the middle term, and then take the square root of the first term, which would be 8x, and put that in the first position, and then take the square root of the last term and put that in the second position, and we have it factored out as x squared minus, 8x minus 1 squared. Okay, again here, starting out looking for a GCF other than 1, and that does not exist for this expression. So the next thing we see is that we've got a trinomial, and again, first thing we examine is whether or not we have a perfect square trinomial. Well, the first term is a perfect square. The last term is positive. However, the 8 is not a perfect square. So since it's not a perfect square trinomial, we jump down to the next box in the flow chart, and it's asking us, is a equal to 1? So yes, we know that since there's no number in front of the x squared, that there's a 1 there. So a is equal to 1. So it says we need something that multiplies to c and adds to b. So in this case, what we need is something that multiplies to 8 and adds to 6. Now, since we have a equals 1, again, the technique here is going to be to set up two sets of parentheses. X will go in the first position of each one. Again, we need two numbers that multiply to 8 and add to 6. So when we think about it, well, 4 times 2 is 8, and 4 plus 2 is 6. So we'll do x plus 4 and x plus 2. To check it, just multiply the two numbers. So 4 times 2 is 8, and 4 plus 2 is 6, and we have the right factors. Again here, looking to see if we could take out a GCF. There isn't anything other than 1 that we can take out. We see that it's a trinomial. We examine it to see if it's a perfect square trinomial, and looking at the 12 tells us that it's not a perfect square trinomial. So again, in the next box, it says is a equal to 1, which it is. So I know that I have to set up two sets of parentheses. X will go in the first position. Now what I need are two numbers that multiply to 12 and add to negative 13. So if I do negative 12 and negative 1, when I multiply the negative 12 to the negative 1, I get positive 12. When I take negative 12 and subtract 1, that gives me negative 13, so I know the factors are correct. Okay, again, looking to see if we could take out a GCF, and nothing will work here. The negative 11 kind of messes that up. So no other GCF other than 1 in this case. We see it's a trinomial, so we look to see, is it a perfect square trinomial? And well, the 2 is not a perfect square, the 12 is not a perfect square, so we could rule out that it's a perfect square trinomial. The next box asks us if a is equal to 1, and no, that's not the case because a is equal to 2. So looking at the third box, it says a not equal to 1. Well, that's the case here. A is not equal to 1, and we have a 2 here. So we're looking for two numbers that multiply to the product of a and c. Right? So here's a, here's c. We have to multiply. We need factors that multiply to that product and also add to b, which in this case is negative 11. So the first step here is to multiply A and C together. So if I multiply 2 and 12 together, I get 24. So now I need factors of 24 that will add to negative 11. So if you think about it, 8 and 3, 8 times 3 is 24. But 8 plus 3 is positive 11. I need a negative 11. So we can do negative 8 and negative 3. If I multiply the two negatives together, I get a positive 24. And when I add them together, I get a negative 11. So that's the combination that we're looking for. The next thing we want to do is to break up that negative 11x by using these two numbers, negative 8 and negative 3. So I'm going to substitute these two in for the negative 11. Now, when I rewrite this, I have 2x squared minus 8x minus 3x plus 12. So now I look at what I have, and I've got 4 terms. So I go to the flow chart, and I see that I'm in the larger column, and it says I need to factor by grouping. So when I factor by grouping, what I do is, now that I have an even number of terms, is I'll group the first two together, and I'll group the last two together. So now what I have to do is take out a GCF for this first term. So I could take out a 2 for the numbers, because 2 goes into 2 and 2 goes into 8. And since they both have a variable attached, I'm going to take the one with the lower exponent. So that's x. Dividing each term by 2x, I have x minus 4. So I have the first group factored out. I'm going to bring that minus sign down, and then I'm going to take out a GCF for the second group. So that would be a 3. And then that will give me x minus 4. And just remember that when you distribute this negative 3 now, what you want to get back is the last part of this expression. So if I multiply negative 3 times x, I get negative 3x. And negative 3 times negative 4, positive 12. So now what we do is we take the GCFs that we pulled out and put them together as one factor. So one factor will be 2x minus 3. The other will be one of the duplicates that we got. So here's one duplicate, here's the other. Bring down one of them. And those are the factors for 2x squared minus 11x plus 12. Okay, another trinomial, no GCF greater than 1, so we have to look at our trinomial column. We can rule out that it's a perfect square trinomial because 3 definitely isn't a perfect square. We could rule out a being equal to 1 because a is equal to 4, so that means we have to use the a times c technique again. So if I multiply a and c together, that's going to give me a negative 12. Now I need factors of negative 12 that add to negative 4. So I can use, how about negative 6 and positive 2. All right, if I multiply negative 6 and 2 together, I get negative 12. If I add them together, I get negative 4. So now what I want to do is take the negative 4x out, use the negative 6 and the 2. So I'm going to rewrite this. Okay, so the negative 4x now becomes negative 6x plus 2x. I notice now I have 4 terms. 4 terms tells me that I have to use grouping. So I'll use the grouping technique, group the first 2 together, group the last 2 together. All right, now I need a GCF for the first group. So for the first group, I could take out a 2 for the numbers. I could take x out for the variable. That's going to leave me 2x minus 3. I'm going to bring down the plus sign. I look at my second group. The only common factor that I have is 1. So I'll put the 1 down here, and inside I'll have 2x minus 3. Again, we take the GCFs that we took out and put them together as one factor. So I'm going to have 2x plus 1. And the other will be one of the duplicates, 2x minus 3. Again, if I were to multiply these two factors using the FOIL method, I would come up with the 4x squared minus 4x minus 3. Okay, and now I have something with 4 terms. I have a 2, a 6, a 3, and a 9. Can't take out a GCF for all of that. And it can't take a GCF out for the variable since the 9 doesn't have a variable. So I have 4 terms. The flowchart tells me I have to use grouping to factor this. So I'll group the first 2 together, group the second 2 together. So greatest common factor for the first grouping, I could take a 2 out for the numbers. Then I have an x cubed and an x squared. I go with the lower exponent. So x squared will be the GCF. And now if I divide 2x cubed by 2x squared, I'm left with x. And then 6x squared divided by 2x squared is 3. Bring down the plus sign. Take out a GCF for the second group. That would be a 3. And then I would be left with x plus 3 in the parentheses. So again, what I do is use the GCFs that I came up with as one grouping. So 2x squared plus 3. And one of the duplicates. Again, if we were to multiply these together using the FOIL method, we would come up with the original expression.